Greetings everyone. In this video we are going to actually program the fuse bits with the USB ASP programmer connected to the microcontroller development board. So for programming we need one software called as avrdude. So this is the link for the documentation of the software. I will be providing this in the description below the video. Do check it out, it's very important because it's a command line tool. You need to look at this as a reference every now and then while programming your microcontroller. So now to install this, you have to go to your terminal window and you have to type the following command. In Debian Ubuntu based systems, you can do sudo apt install avrdude. This is for installing, but I have already installed this application, so I can do sudo apt list avrdude. See, it's already installed. avrdude, it's installed, right? So if you have not installed it, you do sudo apt install avrdude. This is the command you need to execute. If you are using any other Linux distributions, Fedora, OpenSUSE or any other distributions, then you will have to use the appropriate package management commands. Ubuntu uses the aptitude package management command, so that's what I'm using here. So in Fedora I think the command is dnf, and I do not know about OpenSUSE, right? So refer the commands that you have to use from your package manager, right? So once you have done that, come to this page, and this is the command that you have to type in the command line: avrdude followed by -p part number. So this part number refers to the microcontroller that you are going to be using. So the microcontroller that we are using is the ATMega16A. Side by side we'll also take some notes. Okay, so the command that you have to use is over here. You see avrdude. This command also I will be providing the description, so if you want you can even copy paste it. Okay, so for installing in Ubuntu or Debian based systems, you have to do sudo apt install avrdude, and once you have installed it, for programming you have to use the following command in the terminal: avrdude -p part number. So we look at the part number of our microcontroller. The documentation lists it, so we will scroll down. So here M16, right? So M16 stands for ATMega16. This is the microcontroller that we are using. So we will use, or we will type -p M16 for the ATMega16 microcontroller. If you are using ATMega16A, it comes in a 28-pin PDAP package. So then you have to use M168. If you are using ATMega13, M32, and so on. Okay, so look at this documentation. Depending on what microcontroller you are using, choose the appropriate microcontroller. So for me I am using ATMega16, so I am choosing the part number as M16. Okay, now let's scroll down and look at the other options. You can specify the baud rate. It's optional, I'm not going to do now. bit clock, and this is important, programmer ID. This is the programmer that you are going to be using. So you need to put this option -c lowercase c, not uppercase c. Uppercase c stands for configuration file, that you don't have to specify on Linux, because once you install, the path to the configuration file will be set. You don't have to specify it every time. But in Windows, you have to specify the path to the configuration file. But since we are on Linux, we don't have to bother about that. So next option is -lowercase c. So I will put -lowercase c, programmer ID. I am using the USB ASP programmer. Here there are many options. You can even use Arduino as a programmer, or Arduino as a FT232 chip as a programmer, right? So the one that I am using is USB ASP. We'll have to scroll down. Here it is, USB ASP, this one. So the programmer is USB ASP. Okay, this uppercase C, this is the configuration file. This is optional, you don't have to specify on Linux, because the default configuration file is in this location, user local etc avrdude.conf, and avrdude reads the configuration file from this location in FreeBSD and Linux. So since we are on Linux, we don't have to specify anything. We are not going to erase the chip, so we are not going to use the -lowercase c option. Now let's scroll down a little bit. This is what is very important, -uppercase u. This uppercase u, it stands for the operation that you are going to perform. Okay, so this is the syntax for it. Uppercase u should be followed by the memory type, flash, if EEPROM or anything, it's listed over here, right? Memory type followed by the operation that you are going to perform, OP, and then the file name. Here we are not going to give a file name, because we are going to program the low fuse bytes, remember? So we are going to specify one value, one hexadecimal value instead of file name. Then an optional format. So this format we should choose as memory. Okay, right? So the next option is -uppercase u followed by mem type. We will see what mem type. We are not going to program the flash. We will program the flash when we are uploading some program to this microcontroller. Now we are not going to do that. What we are going to do is, see here, lfuse, not fuse. This is for devices that have only a single fuse byte. ATMega16A has 2 fuse bytes, the high fuse byte and the low fuse byte. We are going to program the lfuse, low fuse byte. So we are going to specify lfuse. This is the memory type, colon, see, memory type lfuse, colon, OP. So what operation we are going to perform? Let's scroll down a little bit. See, OP, you have these things, R, W, V, read, write, verify, right? We are going to write a value to the low fuse byte, so we have to choose W. For OP we have to choose W. We are going to write a value then the file name. So when you are going to program something, then you have to use the specify I stands for Intel X. We will be using that while we are programming. But now what we will do is we are going to write a hexadecimal values. Okay, hexadecimal value to the low fuse byte. So for that we are going to specify the value in the place of file name. So what is the value that we have found out? So if you look at this, we are going to write 0xFF in hexadecimal value to the low fuse byte. So instead of file name, I will specify it here, 0xFF hexadecimal value. And then finally, what type of value is this? So we will have a look at here. So look at this, immediate mode, actual byte value specified on the command line. So this should be in place of the file name field. So instead of the file name field, we are giving a immediate hexadecimal value, 8-bit hexadecimal value 0xFF. So in order to specify it is the immediate value, we are going to put M, this option over here, and then we'll scroll down a little bit. See this hyphen or dash small v, this is for enabling verbose output. Verbose means in every step it is going to list what it is doing. Okay, so what I am going to do is I am going to specify this in the beginning itself. Okay, so after choosing part number dash v. Okay, so now let us look at this avrdude is the command for invoking the programming software. Then the part number is M16 for ATMega16. Then I want verbose, I want this software to display what it is doing, then followed by the programmer that I am using. The programmer I am using is usbasp. Then I need to specify the operation that I am performing. So I am going to program the lfuse. I am going to write to the lfuse this immediate value 0xFF. Okay, right? So now I am going to connect the programmer to my PC and I will run this command from the command line, and let's see what happens. Let's hope everything goes well and I don't end up with a brick device. Okay, right, now I have connected my USB ASP programmer to the USB port of my PC. Okay, so I'll go to the command prompt. So I will try ls USB to see if it is listed. Yeah, I think it's this device, this one over here. Okay, I can also do a D message. See, new USB device, product USB ASP and manufacturer, right? So this is the device, it has been connected. Okay, so now I will clear the screen. Now we are going to program or write the value 0xFF into the low fuse bytes. So here goes nothing. avrdude dash p, part number is M16 dash v. I want verbose output dash lowercase c My programmer is USB ASP, and the operation that I am going to perform is I am going to write to the lfuse. I'm going to write to it, so I'll put W. The value, immediate value that I'm going to write is 0xFF. This is the immediate value. Okay. Now I'm going to click enter. Right. Wow. It's done. Let's see what has happened. Right. So the AVR part is ATMega16, and then it's using a USB port, USB ASP programmer, right? And then let's scroll down. And first it is reading, and it has read the device signature, and this is the device signature in hexadecimal, and it is guessing that it is probably M16, that is ATMega16. And then the lfuse value is E1. By default the value is E1. We'll check out the default value from the data sheet. I will go to memory fuse bits. Okay, lfuse value, yes, it is 1110. 1110 is E in hexadecimal. 0001 is 1 in hexadecimal. Okay, so the default value was what? E1. So it was while shipping, it was programmed to use the 1 megahertz internal clock, internal RC clock. So now what you are going to do, see here it is reading the input file, that is input value 0xFF, and then it is writing the lfuse, writing 1 byte to the lfuse, and then it is verifying that it has written 0xFF, right? And then it contains 1 bytes. Verifying is successful, right? See here, you see 1 bytes of lfuse verified. Lfuse reads as FF. We did not test the hfuse value, so it is remaining the default value of 99. But the lfuse, we have programmed it as FF. That's all successful. Right, now our ATMega16A chip is configured to use the 8 megahertz crystal that you are connected to it. Okay, right. So in the next, from the next video onwards, we will start actually programming this microcontroller. Thank you for watching. I'll see you in the next video.